Hey, hello, welcome. My name is Prosper Ngongo, and in this week's lesson, we're looking at electrochemistry. Now, that sounds like the combination of two terminology, electricity and chemistry. Indeed, that's what we're going to be looking at. In this lesson, we're going to be seeing how electricity brings about a chemical reaction, the relationship between electricity and chemistry. And for the lesson, we're going to be basing on the ionic theory. For last week's lesson, we looked at redox reaction, and it was fun, where we balance complex and very simple redox equations. We defined oxidation and reduction, oxidation as electron loss and reduction as electron gain. I told you that oxidation and reduction is based on electron. Other definitions involve the loss of hydrogen, the gain of hydrogen, loss of oxygen, and gain of oxygen. But for most processes, it is preferable to understand oxidation and reduction in terms of electron loss and gain. So for this lesson, let us dive into the lesson and see our objectives for the lesson. At the end of the lesson, you should be able to explain the ionic theory. You should be able to tell me what the ionic theory is all about. The GIF image you see on your screen will give you a concept or give you an idea as to what the ionic theory is all about. Now, the second aspect is you should be able to explain electrovalent and covalent compound as it relates to electrolyte and non-electrolyte. For most of us, we can still remember what electrovalent and covalent compounds are. And so we're going to be looking at this briefly, but relates it to electrolyte and non-electrolyte. Now, this is a terminology that may seem strange to some of you and may not to others, but you stay tuned and learn and see what we have. You'll be learning a lot from the lesson. And lastly, you should be able to define important terms. There are important terminologies that you are not conversant with. We're going to define it so as to help us understand electrolysis even as we advance in this lesson. So first thing first, the ionic theory. Now, what is the ionic theory all about? Now, this is it. It's as simple as this. Now, when ionic substances, ionic solids. Now, ionic solids, I hope you remember what ionic solids are. When some solid, let's leave it at that. We'll define it as we proceed further. And when some solid dissolve in water, they become ionized. And when they form ions, the positive charge ions and the negative charge ions, which are called cations and anions respectively. In the solid state, they are combined and held together by electrostatic forces. At the moment you put them in water, they dissociate by a process called ion solvation, forming the cations and the anions. Although this is not limited to just ionic solid, certain liquids such as HCl acids generally would dissolve in water to form ions by heterolytic fission. At least majorly, it happens majorly for HCl. Heterolytic fissions happen, and hydrogen ion is formed, and chloride ion is formed. Even though HCl is not referred to as an ionic substance, it is covalent in nature, but it has the ability to form ions in solution. So generally, these substances, when dissolved in water, move around randomly. If you see the GIF image we have in the past from the previous slide, you see these ions in water moving around randomly. But the moment you apply an electric current to it, now there is a positive side and a positive electrode and a negative electrode. The negative ions, the anions, tend to move towards the positive electrode, and the cations tend to move towards the negative electrode. So this is what the ionic theory is all about. In summary, what would you say the ionic theory is all about? It's about the formation of ions when a solid substance, usually an electrolyte, is dissolved in water. Not just solids, certain liquids. Let's proceed further so we understand better what the ionic theory talks about. So moving on, what are electrovalent and covalent compounds? Of course, you know what electrovalent compounds are. Now, if you don't know what electrovalent compounds are, I'm going to remind you. The reason I'm confident that you know this is because we've seen electrovalent compound, covalent compound in our previous lesson. We've discussed it. Is something that we see daily, something that we discuss daily. So, but let me try to remind you of what electrovalent compounds are. Electrovalent compounds are compounds formed between metals, usually metals and non-metals, involving the transfer of electrons from the metal to the non-metal, as we see in the GIF image here. where sodium loses its valence electron. Sodium has an atomic number of 11 and fluorine has an atomic number of 9. So sodium loses its outermost valence electron to fluorine. Now sodium becoming 10 and forming an ion, and fluorine gaining an electron to form also an ion. So this is electrovalent bonding, the transfer of electron from an atom, usually a metal, to another, usually a non-metal. So that's electrovalent, also referred to as ionic bonding. So what about covalent bonding? Covalent bonding is also called a molecular bond. It's a chemical bond that involves the sharing of electrons. Unlike electrovalent bonding, one atom transfers electron and resulting in the formation of ions and not a molecule. For covalent bond, on the other hand, using hydrogen as an example, now hydrogen atoms has one electron each, so they come together to share. So covalent bonding, covalent compounds involve a compound that has shared an electron. Such bonds are usually formed between two non-metals. Let us see how this relates to our topic for the day. So how does this relate to the degree of conductivity? So we're going to be looking at electrolytes and non-electrolytes. So what are electrolytes? The first thing you should know is that electrolytes are substances that conduct electricity and are decomposed in the process. They could be in molten form or in aqueous form. As we advance, we're going to see the definition later on. So what are strong electrolytes then? Now strong electrolytes are substances that usually they're completely ionized in water. Now we have on the screen that this means that 100%, well, let's not be so confident about 100%, about 100% of the dissolved chemicals break into cations and anions. Strong electrolyte conduct current. Example include, so what we have as an example, we have strong acids, HCl. You see HCl, HNO3, H2SO4, they are all strong acids, but they are not ionic. They are covalent compound, but they have the tendency of dissociating. Should I call it dissociating? Okay, they have a tendency of forming ions. They form ions in solution, so by heterolytic fission. Now we also have strong bases are also strong electrolytes. So it's as simple as this: strong acids are strong electrolyte and strong bases are strong electrolyte. We also have ionic salt. Now we have here ionic salts. So we have sodium chloride as an example, magnesium chloride, potassium bromide as an example. So if you know strong electrolytes to be substances or electrolytes that are completely ionized in water with the formation of cations and anions, then what are weak electrolytes? Well, we have here that weak electrolyte partially ionized in water, so do not conduct electricity readily. Examples. Now if we have here strong acid as strong electrolyte, strong bases are strong electrolyte, you could just go for the opposite of that. And you have example weak acid, of course, and we have nitrogen containing compound. There's no example for that. I don't give an example. It is intentional because it's not important for our class right now. And then the last one is weak bases such as ammonium hydroxide. Sorry, those values are not in order, but that is ammonium hydroxide over there. Now we also have non-electrolyte. Now we're not looking at the non-electrolyte aspect because it is not important. Nonetheless, you find such question in WAEC or in your JAM. So what are non-electrolytes? Now non-electrolytes are substances that would not conduct electricity in molten or in aqueous form. Electrolyte that would substances that will not conduct electricity. Such substances include organic substances. Most organic substances, I'm not talking about acids or organic bases, but I'm talking about organic substances such as the alkanes and the alkenes. I hope you still remember those ones. So they will not conduct electricity and they are referred to as non-electrolytes. So if you see question in WAEC talking about which of the substance or asking you to pinpoint which of the substances are non-electrolyte. Go for substances such as sugar, carbohydrates, and the rest of them. Organic substances, go for organic substances, not acids. Don't go for organic acids. Look for organic substances such as sugar. Usually sugar will be part of the option, and you can have other carbohydrate as part of the option. Go for those ones. They are non-electrolyte. So for strong acids, they are strong electrolyte. For weak acid are weak electrolytes, and it goes the same for strong bases and weak bases. So advancing, and we have definition of important 10. Now, what is electrolysis? Now, this definition will help you. Now, this is a place you need to calm. You need to calm yourself and learn this definition. Not just memorize it. I don't want you to memorize it. In fact, I prefer you understand what this means. And so I'm going to pinpoint each word. I'm going to go about it one after the other. We have here electrolysis. This is chemical decomposition. I repeat, the chemical decomposition produced by passing an electric current. Usually this electric current is a DC current, a direct current, through a liquid or solution containing ion. The word liquid here could be, you could replace it with molten. As some solids, when you heat them until they melt, such as sodium chloride, you could have molten or fused sodium chloride. When you heat sodium chloride, I don't mean dissolving into water, you heat it, and it melts down to form ions, sodium ion and the chloride ion. So chemical decomposition produced by passing an electric current through a liquid or a molten substance or solution containing ions. So that is electrolysis. You have an electrolyte, you pass electricity through it, the cations are attracted to the cations are attracted to the cathode, and the anions are attracted to the anode, bringing about decomposition. That is electrolysis. So what's an electrolyte? We've seen that in the past. But how we have here, an electrolyte is a compound which conducts electricity in molten form. Now note that, in molten form. I'm talking about solids here. I'm talking about solid, talking about molten, that is melted form, or in solution. In solution means to be dissolved in water, just like you see the states in your chemical equations, such as aqueous. When you hear the word aqueous, it means that the substance has been dissolved in water. So in solution and is decomposed in the process. So an electrolyte is a compound which conducts electricity in molten form or in solution and is decomposed in the process. Now, what are electrodes? As simple as it is, as basic as it is, the electrode is just, could be a solid, although you can have it as a liquid also, such as mercury. They are usually metals. The electrodes is a solid electric conductor that carries electric current into non-metallic solids or liquids. Electrodes are typically good electric conductor, but they need not be metal. So it's not necessarily metal. Now, what it means there when you say into non-metallic solid, what this means is just simply we're talking about the electrolyte. Electrode is a solid that carries electricity into the electrolyte. As simple as that. Electricity goes into the electrolytes through the electrode and leaves the electrolytes through the electrode. So, but we know here from the statement, we know that electrodes are not necessarily solid. They could be liquids. They are usually metals, but not necessarily metals. We're going to see about this electrode. We have inert electrodes and we have active electrodes. Examples of electrodes, we have graphite, we have platinum, copper. Metals generally, most metals are electrodes. So what is the anode? The anode, now this is where you need to know. We know what oxidation is, and that is why we defined oxidation, why we talked about redox reaction before this lesson. So the anode is the electrode where oxidation occurs. So if oxidation occurs at any of the electrode, at that point the electrode will refer to as the anode, whereas the cathode is the electrode where reduction occurs. In other words, where there is gain of electrons. So that is our cathode. So thank you very much for watching. It has been a brief lesson, and that's how I want it. Now you're going to be answering questions. Remember, your assignment and everything is going to be done in the Google Classroom, and I do hope that you for any point, if at any point you don't understand this lesson, you're free to ask me questions in the Google Classroom, or you can chat me up on WhatsApp. I prefer the Google Classroom, or send me a mail. Whatever you do just gets to me, and I'll answer questions in regards to what we've done so far. Although this is an introduction, if you need to learn more about this, you can go online and read on it, or you can go back into the video, pause it and read this definition, go through it one and one slowly, and I'm sure you will get a lot from it. Thank you very much. Do have a nice day and stay safe.